Welcome to Coach Taylor's Class Notes, and today we're going to talk about dilations. A dilation is an enlargement or a reduction of a figure with respect to a fixed point called the center of dilation. A dilation is an example of a non-rigid motion. And so what that means is that the shape is they're not going to be congruent. Our shapes are going to be similar, which means their sides have the same proportion and the angles are congruent. A dilation again produces similar figures instead of congruent ones like all of our rigid motions create. Again, corresponding angles congruent, corresponding sides are proportional. So if we look at this picture here, the dilation caused the triangle to get bigger, and if we notice from the origin, they all follow the same line. So scale factor is a key thing when we are looking at dilations. So the variable for scale factor is the letter K. So when K is greater than 1, the dilation is an enlargement. When K is less than 1, the dilation is a reduction. And so we can write a rule for dilations, but it's one that's pretty straightforward. And so pre-image x comma y is transformed by multiplying each point by the scale factor. So we get kx comma ky. And anytime we have two letters next to each other, that means multiplication. So let's look at a couple of points and let's look at how we can find scale factor. So the way that we can find scale factor is by using this formula here. K equals prime over original. So what we need to do real quick is we need to find D and D prime. So D is 1, 2, 3, 4, 5. It is 0, 6, and D prime is 0, 2. So again, it's prime over original. I'm going to do the y points only because I know that 0 divided by 0 just simply gets me 0, which does not help. So going from D prime to D, it looks like my scale factor is 1/3. But I'm going to go ahead and very quickly check the other points just to make sure. So E and E prime, which is 2, 0. Nope, E prime is 2, 0. So again, you've got to be very careful and look at how you're reading it. So E prime is 2, 0, which means E is 6, 0. So again, prime over the original, which gets me 1/3. And so it does, yes, look in fact like 1/3 is my answer, but let's real quick be very meticulous and check one more just to make sure. So F prime is negative 2, -1, and F prime is negative 6, -3. So again, it's prime over original. So negative 2 over negative 6 equals a positive 1/3, which yes, seems to fit. And then we have a negative 1 over negative 3, which yes, becomes 1/3. So yes, my scale factor on this shape, K equals 1/3. All right, so now we need to do the same thing, and what I notice is that my bigger shape is my prime figure, whereas my smallest shape is my pre-image. So we need W prime. So W is negative 2, 2, and then W prime is 1, 2, 3, 4, 5, 6, 7, negative 8, 8. So I need to put my prime, which is 8, negative 8 over the original. So that would be a positive 4. And then again, 8 over 2, which still is a positive 4. We're going to check the other ones just to make sure. So x equals x prime equals 2 comma 0 and 8 comma 0. So 8 over 2 is 4. So we're looking good so far. Y equals y prime equals 1 comma negative 2. And this is 1, 2, 3, 4 comma negative 8. So 4 divided by 1 is 4. Negative 8 divided by negative 2 is positive 4. And so we're in good shape there. We just have one last one to check to make sure. Z and Z prime. I'm just going to mark that out instead of erasing. Negative 1 comma negative 1. And it looks like negative 4 comma negative 4. And yes, I know that 4 over 1 is 4. So my scale factor here is 4. All right, so when they're giving us our scale factor, we're told that we need to multiply the scale factor by the points in the vertices. So point R, if I multiply a negative 5 times 2 becomes negative 2. 1 times 2 is 2. So my R point should be negative 10, 2. Oh, I put the original R in the wrong spot. So I'm just going to keep it there, and we're going to go negative 10, negative 2, even though that's not what the problem is. So negative 10, negative 2 for R prime. For S, negative 6, 8 is going to be S prime. Sorry, I forgot to put my R prime on there. So negative 6, negative 8. 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8 is S prime. And then T prime is going to be 2 times 2 is 4. 2 times negative 1 is negative 2. 1, 2, 3, 4, 1, 2. Quit it. So that is T. Nope. 4. Yeah. So this right here would be T prime. And so if I connect all of my dots, ooh, that's a really bad line, especially considering I had a line already. So if I were to draw a line from the origin through all of my points, they should all be on the same vertical line. And so that's how we know dilations work, is that they're all on the same linear line from the point, the center of dilation. All right, so triangle WXY with vertices there, and we have a scale factor of 1/4. So if I'm looking at W prime, multiplying by 1/4 is the same thing as dividing by 4. So I should have a negative 1, 2 for W prime. I should have for X prime, X divided by 4, so 10 over 4 is going to become 5 halves, which is the same thing as 2.5. You can either write it as 5 halves or 2.5, whatever helps you out. And then anything divided by 0 is 0. So 1.2.5 and 0, Y. So that's going to be X prime. And my last point, Z prime. Negative 2 divided by 4 is going to be a negative 1/2. Negative 8 divided by 4 is going to be a negative 2. So negative 1/2 and a negative 2, Y. Puts Y right there. So again, if I connect my points, again, I should be able to draw a straight line from the origin, and it should hit both the original and the prime dots. And that is one of the ways that we know that our dilation worked. So real quick, we're going to ignore all of this stuff down here. We're not going to do it. So we need to tell if it's an enlargement or a reduction. Remember, an enlargement is K is greater than 1. A reduction is K is less than 1. So 5 is definitely greater than 1, so that's an enlargement. 5 over 2 is 2.5, so that would still be an enlargement. 1/2 I know is definitely less than 1, so that's going to be a reduction. And then 2 over 5ths is like 0.4, so it's still less than 1, so it's going to be a reduction. And so that is the introduction to dilations.